This is video 1 for strong versus weak acids and bases, and this is a PowerPoint, and we took 2 days on this one PowerPoint, so I'll upload the PowerPoint, but I will stop it for this video and then I'll upload part 2, but I will upload the video as one PowerPoint. So if you missed the very first day when we did strong versus weak acid and bases, this is part 1. So we're going to just begin. And we did do this in pre-AP, strong versus weak acid and bases. When they break apart differently from one another. And a strong acid and a strong base completely break apart in water. So in water, HCl, there is no HCl together. It's actually completely apart. And you need to know your 7 strong acids. So if you don't know those, you do need to know your 7 strong acids. And again, you should know those because of netonics. That's the very first part of netonics. Hydrochloric acid is HCl. Hydrobromic acid is HBr. Hydroiodic is HI. Sulfuric acid is H2SO4. Nitric acid is HNO3, perchloric acid is HClO4, and chloric acid is HClO3. Those are our 7 strong acids. Our strong bases are hydroxides in the alkali metals and the alkaline earth metal hydroxides, with the exception of beryllium and magnesium. And so when we go to do the pH for a strong acid, because it ionizes completely, we do not have to write strong acids or strong bases. So they're a very simple calculation. So we've got a couple examples here. The first example here is hydrobromic acid, which is one of our strong acids. When he breaks apart, we simply can write him like this. We can just simply one arrow. Whoops, that was something transferring over there. Alright, we can simply write him and break him apart just like this. This is one way to write him. Or if you prefer the Arrhenius definition, you can put plus water, and then you can make hydronium, and you can make the bromide ion. So this is acceptable and this is acceptable. Because it's a strong acid, they never go to equilibrium. It goes to completion, and there's none of this in the solution once we drop it in there. So this is going to be 0.0256 molar, because it's a 1-to-1 ratio. This will be 0.0256 molar. And when I get ready to take the pH, you simply take the negative log of 0.0256, and that will get you the pH. Negative log. Don't have this memorized, so I'll have to push these in. You'll get 1.59, or you can simply put 1.6 for your pH, because we want the H+. If you're doing it over here, that would be our hydronium. So you can take the negative log of H+ or hydronium. But that's simply all we got to do. I do want you writing the equations out as well, so you can write it out this way or that way. Alright, for our bases are a little different. This is a lithium hydroxide, so we could simply just break him apart as well. Strong base is going to make lithium. It's going to make hydroxide instead of H+. This is going to be 0.0 strong, so there's none of that togetherness. Completely goes. Notice the arrow is only going one direction. Now, the difference is, this is not going to get me pH, it's going to get me POH. So you have to take the negative log of that, and then to find the pH, you're going to have to do one more step. So, negative log of 0.00632 gets you 2.19, or actually gets you 2.2. So to find the pH, you actually have to subtract it from 14, and you will get 11.8, I do believe. So if it is a base, you don't stop at this point, because you want it to have a base pH. You will go one step further. Okay, we did a third example. And this was strontium hydroxide. Strontium hydroxide, I'll say it in here. On the strong acids and bases, they all ionize 100%. So when I ask for percent ionization on the strongs, they all ionize 100%. What that means is they break apart 100%. So number 1 and number 2, they ionize 100%. This looks almost identical. The difference is this is not lithium hydroxide, it's strontium hydroxide. So when he breaks apart, he does still break into strontium ions, but because of this 2 here, it makes 2 OH minus ions. So this is going to be 0.00632 molar, but this is going to be twice that amount, so 0.1264 molar. And this is the one you want to take the POH equals the negative log of 0.01264. And you get 1.9 for the POH. It's hydroxide, so to find the pH, you're going to take 14 and minus that, and you will get 12.1. So you can see a slightly higher pH, still 100% ionized as far as the percentage. On the weak acids, weak acids and bases do not ionize 100%, so you have to rise the equation. Your percent ionization is going to be found by taking your X divided by your initial amount. It's how much is actually breaking apart, so it's always going to be X divided by the initial times 100. And again, this PowerPoint will get put up. We're going to do acetic acid. It is a weak acid, so we are going to have to rise it. And acetic acid, C2H3O2, there's acetic. We're going to have 2 arrows instead of 1. And we're just going to take his hydrogen off of him to write our equation. Or you could put plus water and make hydronium if you prefer. This is just the easier way to do it. This is going to start out as 0.1 molar. We'll go here. This will start out as 0. Because you have that, we know the K, so we can minus X here and add X here. This will be X, this will be X, this will be 0.1 minus X. Then we're going to take the product side, which is this, which is going to be X squared. We're going to take it over this, which will be 0.1 minus X, and we'll set that equal to the KW, or I'm sorry, the KA, because it's an acid. Okay, now you can use your solver if you want, but since this is to the -5th here, you can actually scratch through this. Then you could cross multiply. So whichever you feel more comfortable with. If you feel more comfortable with the solver, you can use the solver. Or if you would rather do it this way, it will work for all of these, and I'll show you why in a second. And then we'll take the square root. We find our X is 0.00134. Doing it this way, if we do it the other way, you get 0.0013. If we trace we could find this guy, 0.1 minus that if we wanted. The H plus is going to just equal that. This is going to just equal that. This is the guy we need for pH. So to find the pH, I'm going to take the negative log of 0.00134. So negative log of 0.00134, you will get 2.87, so we'll just do 2.9 for our pH. To find the percent ionization, it's always this amount here. That's how much is breaking down, so it's X divided by, so we want to know what percent this is of this number, and since we know that now, it's going to be our X divided by our I, our initial amount, how much do we have in the beginning, this much broke down of our original, and we'll just divide. This comes out to be 1.34%. And as long as your percentage is less than 5%, you can always mark through the X here. If I had done the percentage and this had been like 8%, I'd have to go back and actually use the solver, and I wouldn't be allowed to do this. So that's pretty much the lesson that we learned on the first day, which was the weak versus strong. So we'll stop there. There is a worksheet that I will try to upload. If not, you'll need to come by and get it. That went with this, and then there was a quiz over this. So I'm going to stop this video, and then we'll begin the next video, which will be for the next day.